Number 8, a convex mirror, it's supposed to be convex here, is formed from a polished metal sphere. We talked about, think of convex mirrors as Christmas ornaments, some kind of sphere, and you're looking at it from the outside. What kind of image does an object placed 20 centimeters in front of this mirror produce? Alright, so what we have here is we have the radius, r, so we know that the focal length is r over 2, is going to be 30. However, be very careful with your positives and negatives. It's a convex mirror. We said convex mirrors had negative focal lengths. And we have the object distances, P is 20 centimeters. So there's two ways to solve this problem. We could use the equations and see what we get for Q. If we get a positive Q, that's a real image. If we get a negative Q, then that's going to be a virtual image. So let's do that. With these two numbers, we can solve for Q. And using the thin lens equation that we just used in the last couple of problems, we already know that we get Q equals PF divided by P minus F. Using the thin lens equation, we get negative 12 centimeters. And this was done in problem 6 if you haven't seen it. So that tells us right there that the image is virtual because it's a negative image. Now, what we could also do if we wanted to is we could draw a rough sketch. So if I draw my convex mirror here going this way, and I have my object over here, and let's say that this is 20 centimeters away, then let me do it a little bit bigger. Then let's see what happens. So if this is 20 and the focal length is 30, so we gotta try to scale here, this would be 30 about right here. So this would be the focal point. So we're going to have a ray that comes in parallel. It can't go through the focal point, but it's going to reflect along a line as though it is reflecting from that focal point. And then we're also going to have a line that goes toward that focal point. So if I draw a line this way, that if it went through, it would go to that focal point. But as soon as it hits the mirror, it's going to reflect parallel. So I'm not going to draw the one going through the center because it's too messy when you do rough sketches. But as a rough sketch, if we trace these two rays back, then we're tracing this one straight back here. We're tracing this one. You can see that we get an image formed right here. So this was 30, this was 20. It looks more like closer to 15 the way that I did it, but it's because it's not to scale 100%. But at least by doing a rough sketch, you can see that it really is a virtual image because we had to project those rays back. Number 9. So this is a similar problem here. This time we have a lens. And what kind of image is going to be produced? So we can do the same thing as the previous one and find Q using PF over P minus F using the thin lens equation. It's a converging lens, so that focal length is F, it's a positive number, and this is P. Plug in P and F into this equation, we get 40. We get a positive number, that means it's a real image, 40 centimeters. If you want to do a quick sketch, we have a converging mirror, we have our optical axis, we have the focal length over here, and we have the object, which is right here. So let's see what happens. Oh, sorry, this is a lens, so I drew a mirror, but I should be drawing a lens here. It's a converging lens, which means I'm not going to have enough room here. I drew it too big. So let's do this again. Let's try this again. I was thinking we're still doing a mirror here, so there we go. So this is going to be the image, the object right here at 40 and the focal point right here. So you draw the focal point on each side. So you're going parallel, and then you're going to refract right through that focal point. And then you're going to go through the focal point on this side, and you're going to refract parallel. And you can see where they're intersecting. You can do the one through the center since this one's not too messy. The one through the center also goes right through here. And you can see that the image produced is indeed real, and it does happen to be the same distance. So the quick sketch is good to know if the image is real or virtual, but if you need numbers, then it's better to use the equation.